In this unit, we're studying further topics in trigonometry. In this lesson, we're going to take a look at finding trigonometric functions given their graphs. All right, hi everyone. So this video here is because there was an update to the resource that we're using in class, and I want to make sure that, that I have a video that reflects the changes that were made in the questions here. So what we're going to do is we're going to look at how to come up with the equations of trig functions based on their graphs here. Okay? And in this particular case, and this is a really good question, I'm going to ask you to come up with a positive sine graph, a negative sine graph, or equation, I should say, positive cosine and negative cosine equation based on just this graph. So where we start with this is I want you to identify the maximum and the minimum values here. So in this particular case here, the maximum value is going to be 1. Okay, and remember, I'm talking about the y-coordinate here. Maximum value is going to be 1. And the minimum value when I go down here and take a look, it's going to be negative 5. Now, the reason why this is significant, and for this particular question here and for the video here, I am assuming some familiarity with the transformations and what they do, okay, sorry, or how we incorporate the transformations into these functions here, and some of the vocabulary, okay? So in this particular case here, remember that our amplitude is going to be the max value minus the min value over 2. Okay, and that's just an equation that we're given. It's the distance from the median line to the top, or the median line to the bottom here. And in this case, that is going to be 1 minus negative 5 over 2. Well, 1 minus negative 5 is going to be 6, divided by 2 is 3. Our median line, the d value, okay, which is basically going to be where the vertical middle of the graph is, will be the maximum value plus the minimum value divided by 2. It's kind of an average. So 1 plus negative 5 over 2. 1 plus negative 5 is negative 4. Divided by 2 will be negative 2. Now, immediately, and when you take a look at the equations here, you'll notice that I've already got 50% of the variables that I need. So that's kind of wonderful here. And additionally, what I'm going to do here is I'm going to draw a line across here at the d value. Okay? I'm going to let it be y equals negative 2. That's my d value. So I'm going to let that sit there for just a moment. I'm going to refer back to that in just a bit. The next thing I'm going to do is come up with the period. I'm just going to read this off the graph as best I can here. And notice that the period is I'm going to read that from peak to peak. I could do this a few different ways. I mean, I could do it from the middle portion here to the middle portion right there, as long as I take into account a full period. And a full period occurs when the graph here goes through 4 quadrants, okay? So remember that for a cosine graph here, the first quadrant is positive, negative, negative, positive, okay? Each time I go from the peak to the center, center to the bottom, bottom to the center, each one of those is going to represent a quadrant. And if you're not familiar with what I'm referring to there, if you think about how we measure angles here, we start on the positive x-axis and we rotate out. When that terminal arm rotates through the first quadrant, then the second quadrant, third, and fourth, okay, that's what I'm referring to. It's just now instead of a rotating arm here, what we're doing is we're just putting the angles along the x-axis and then plotting the either sine or cosine values that we get. Now in this case right here, I got a peak. It's one mark here to the left of pi, and I got another peak here, 1 mark to the left of 5 pi. Okay? So, really, that's just a separation of 4 pi. I mean, if I moved this whole graph like 2 marks over to the left here, this would start at 0 and it would go out to 4 pi. So I can just read that right off the graph here. What that allows me to do is to get the b value, because the b value will be 2 pi divided by the period, which in this case is 4 pi. And when I do that, I get 1/2. Okay, so my b value is 1/2. So all of a sudden, I know a significant portion of each of these equations here. And in fact, what I typically do at this point with students, I write it out just to emphasize the fact that these pieces that I just found will be the same regardless of the equation that I'm looking at. So this will be y equals 3 sine of 1/2. Okay, then I've got the phase shift in here, and I'll talk about the phase shift in just a moment. Minus 2. When I'm talking about a negative sine graph, it'll be negative 3 sine of 1/2 x, put the phase shift in there, minus 2. For cosine, it'll be, this is positive cosine, 3 cosine of 1/2 x. I'll put the phase shift in there, minus 2. And then down here I've got y equals negative 3 cosine of 1/2. And I will put the phase shift in there once again, minus 2. So I've got basically most of each one of these functions here. Now what I got to do is I got to figure out what the phase shift is for each of these. The phase shift really is a result of the choice of graph that you're looking for. So for example, when I'm looking for a positive sine graph, if you put a box around it where this is like this is the y-axis here, this is the x-axis, sine looks like this. It starts at the center and it goes up, down, up. That's what a positive sine graph looks like. The negative sine graph, if you put a box around it, and remember that box starts here on the y-axis, there's the x-axis, it goes down, up, and then down. Cosine, on the other hand, if I put a box around it, again, with the left side on the y-axis here, cosine starts at the top. It starts at 1 and then drops down and then goes up like that. Whereas negative cosine, again, putting a box around it where that is the origin right there, it starts low and then swoops up and comes down like that. So I'm looking for these particular shapes here, and I'm looking for them up here. Now I'm going to identify some points here on the graph that are going to be significant in this investigation, and I'm going to call this A, B, C, D, E, F, G, H, I. I do this so that you can see that when I'm making my choices here, these are the types of points that I'm looking for. I'm not looking for anything in between, okay, a peak and the middle, or the middle and the bottom here, okay? So now, let's start with positive sine. Which of these could be the starting point for a positive sine? And so what I'm looking for is I'm looking for a point that looks like this, that starts along the center, along the median line, and then the immediate action to the right is to go up. Well, B is on the middle, but its immediate action is to go down, so it can't be B. Could be D, can't be F, could be H. So I'm looking at D and H here. Now it turns out either one of those would be okay, but typically we default to the one that's closest to the y-axis, regardless of what side it's on. So in this case right here, I am 1 unit to the left here, and when I take a look at my scale, here's pi, and I'm 3 squares away from the y-axis, so each one of these little marks here must be pi over 3. Okay, so now this D value here, remember, the sine graph should start on the y-axis, and it's been moved to the left. So remember how your transformations work here. This is going to be x plus pi over 3. Remember that when we're using the kind of our in a sense function notation here, whenever we're working with a function here and we're putting in a horizontal translation, it's going to be x plus that value. For negative sine, again, we're looking along the middle of the graph here, but we're looking for a value, or we're looking for the point where it immediately drops below. So again, going back, it could be B or it could be F in this case. Now in this case, between these two, F is the closer one. And now that we know what the scale is here, we can just count this out. This is 1, 2, 3, 4, 5. It's been moved 5 pi over 3s to the right. Well, to the right, I'm going to put subtraction there. 5 pi over 3. Now that we've done a couple here, just to identify this, I frequently get students that will think about this in a slightly incorrect way. They've got everything kind of in place, but their thinking is that they need to transform it back to the y-axis, and that I have to move this to the left to get it back there. That's actually not what the question is. The question is, for example, that starting point should have been on the y-axis and it has been moved. How has it been moved? So it's been moved 5 pi over 3 to the right. The next one we want to look at here is positive cosine. In positive cosine, if we look back at our little graph here, positive cosine starts at the peak. So let's go up here. Which of these three could be a starting point for, I shouldn't have said that. I should have said, which of all of these could be a starting point for cosine? And it's these top three is what I meant to say there. But E is going to be the closest one to the y-axis, so we're going to use that one. And I can see that it's 2 spaces to the right. So this thing has been transformed to the right 2 pi over 3s. Okay? And now finally we're going to look at our negative cosine here. And negative cosine starts at the bottom. So in this case here, it's either going to be point C or G, but C is closest to the y-axis. And it's 1, 2, 3, 4 spots to the left. So to tell the formula here that we want to go to the left, we're going to go x plus, and this will be 4 pi over 3. Okay? Now, let's take a look at some other examples. We're going to do the same thing with this one here. This time the question is asking for a positive sine graph. So we can move a little bit quicker. We don't have to find them all. In this case here, my maximum is going to be 5. My minimum is going to be negative 3. And so I can tell you right now, my A value is going to be 5 minus negative 3 over 2. So 5 minus negative 3 is going to be 8 divided by 2 is 4. The D value will be 5 plus negative 3 over 2. Okay, well 5 plus negative 3 is going to be 2. Divided by 2 is 1. And so I will draw a line that goes through 1 there. That helps me find the sine values, okay, where sine would start. My period, I want to count this out here. And now this one's actually a little bit easier even because I've got a peak here at negative pi and a peak here at 3 pi. And so there's 1 quadrant, 2 quadrants, 3 quadrants, 4 quadrants. So there's a full period. And it happens between negative pi and 3 pi. So that's a period of 4 pi. And actually, we already looked at that. We just did a problem where that was true. And so that tells us that the B value here is going to be 1/2. So now I've got the 3 pieces here. So y is going to equal 4 sine of 1/2. I got to incorporate that phase shift in there. Plus 1. And so again, I'm going to look at and I'm going to label those key points here. A, B, C, D, E, F, G, H. Except now I'm looking for sine, so I know sine starts along here. So it's going to be A, C, E, or G. And positive sine swoops up. So that could be either A or E. Now, but have a quick look at this. These are symmetrically kind of distributed around the y-axis here. So actually A or E would be totally fine. Typically what this means is we just expect you to choose one. Okay, you don't have to choose both here, but this could be positive or negative 2 pi, okay, to indicate that it's been moved 2 pi to the left or 2 pi to the right. You basically got to make a choice. That is more our problem as teachers to know that there are 2 possible ways of writing that. Okay, you just got to choose one. Let's take a look at another one. We're going to assume the minimum possible phase shift, and we're going to write the equation in the form, and this is a cosine graph, and again, it's a positive cosine graph, which means I know that it's going to start right there. Okay? After the couple questions that we've just done, I know that we're going to start at the peak. So again, we look at my max and we look at my min. My max here is going to be, 5, 6, 7, 8, 9. So 9. My min is negative 3. So my A will be now 9 minus negative 3 over 2. So 12 over 2 is going to be 6. My D value will be 9 plus negative 3 over 2, which will be 3. And then I'm going to come up here and I'm going to highlight that 3. And actually, I'm doing that on purpose because I'm actually going to tweak this question just a little bit in just a moment here. Now my period is going to take a little bit more work because notice that what I've given you is I've given you a min up to the middle, up to the max. Well, that's just 2 quadrants. When you think about the terminal arm rotating around, this is just 2 quadrants here. So, yeah, this is not a full period. It's only half of a period. Now, when I look at my scale here, each one of these blocks here, each one of these marks represents pi over 4. Okay, and I know that because here's pi, and there are 4 blocks there. So what I've got here is to go from a min to a max is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 of them. So 8 pi over 4 is 2 pi. So my half period is 2 pi, which means my full period must be 4 pi. So yeah, you can see this common theme coming up here. It's mostly coming up because for the most part, that's not our main focus here in this particular lesson. Our main focus is typically going to be about the horizontal phase shift and making sure that makes sense. So we are repeating here, but we know that that means that this is going to be 1/2. Now, here's my equation then. This is going to be y is equal to 6 cosine of 1/2 x. It's going to have a horizontal phase shift, and then we already know that the d value is going to be plus 3. So I basically have to just figure out, well, how far to the right of that y-axis is this? Well, it's 1, 2, 3, 4, 5 of those blocks, and we know that each one of those is pi over 4. So minus 5 pi over 4 to go to the right. What I want to do really quickly is I want to ask people to come up with a negative sine graph with this. So negative 6 sine of 1/2 x plus 3. And the reason why I ask for a negative sine graph here, and I'm just extending this problem a little bit, is because this would be the beginning point for a negative cosine. This would be the beginning point for a positive sine. This would be the beginning point for a positive cosine. Of those 3 points, none of those would be a negative sign. Negative sign isn't being shown here. I can get it by extending the graph a little bit. Now notice that the midline here, the midpoint, is slightly to the right of the y-axis, which means between these 2 points, each of which would be a good starting place for a negative sign, this one's closer. Well, how far back is it? Where is this? What is the x-coordinate here? Well, this point right here is at pi over 4, and I know that a half period was 2 pi. Whoops, sorry, you can't see it. Pi over 4. So if I start with pi over 4 and subtract my half period, my 2 quadrants here, okay, I'm going to get a common denominator, so this will become pi over 4 minus 8 pi over 4. I will get negative 7 pi over 4. This starting point rate is down here at negative 7 pi over 4, which means it moved to the left. So I do this as positive 7 pi over 4 to get the proper transformation. Okay? So in this one right here, assume the minimum possible phase shift and write the equation in the form y equals, this is a cosine, but this one's a negative cosine. Okay, let me just fix this here. This is going to be a negative cosine. Again, I jump into it the same way I've done the other ones here. My maximum is 5. My minimum in this case is negative 1. A will be the max minus the min over 2. So it's going to be 3. D will be the max plus the min over 2. And that's going to be 2. So I draw my line through here at 2. Although in this particular case, I don't really need to do that. Because in this case, I am going to be just sticking with the function as is. Actually, I can see the period right now because I've got the low point here, a min, goes up. So that's 1, 2, 3, 4 quadrants. And it basically hits the another min here, the next one at 2 pi over 3. So if I want the b value, that's going to be 2 pi divided by 2 pi over 3. Okay, the 2 pi's cancel. I'm dividing by 1/3, which becomes 3. So now I write out my equation. Y is equal to, now this is a negative cosine, so this will be negative 3 cosine of, and this will be 3, leave space for my horizontal phase shift, plus 2. And now I know that the cosine graph, negative cosine, starts at a min. Well, this min right here is the closest to the y-axis. In fact, it's right on it. So it turns out, actually, that is the correct answer without that space there. There is no horizontal phase shift. And you're going to see that frequently with questions on exams and whatnot, frequently we will set up equations like this because we know that it's sometimes difficult to find the horizontal phase shift. So if there's something else that we're going to test, like if we wanted to test that you knew all these things here, we might leave off the horizontal phase shift just so that you can focus on these things. And then we have another question that's more specifically about the horizontal phase shift. So we just wanted you to see something like that. And that's what you would do. You'd leave it like that. Okay, let's take a look at just a couple more questions here just to round this out. I know this is running a little long here, but I just wanted to make sure that we had these equations here. In this particular case, I'm asking you to come up with the equation, but I'm giving you a minimum of information, okay, or at least as little as I can. I haven't even given you the graph. I'm telling you that the amplitude is 3. Well, that's nice. So I know that A is equal to 3. I know that we've got a maximum at negative pi over 2, comma 5. 1, 2, 3, 4, 5. So it's going to be right here. And the nearest maximum to the right, so the next maximum is at 3 pi over 2. Okay, so that's pi. So 3 pi over 2 would be right here, comma 5. Okay, so there we go. There's a max, there's a max. I know that my amplitude is 3. I'm going to try to come up with all the rest of my information from here. Well, if this is the maximum and my amplitude is 3, it means if I go down 3, 1, 2, 3, here's the middle of the graph. And that tells me right away that my d value must be 2, okay, because I can draw that through there. Now, if I go down another 3, 1, 2, 3, draw that line there. This is where the minimum of my graph is, because remember, from the top to the bottom is going to be twice the amplitude. Now, to go from negative pi over 2 to 3 pi over 2, we want to figure out what the period is. Well, the period is going to be the difference between those. So 3 pi over 2 minus negative pi over 2, 4 pi over 2, which is just 2 pi. That's wonderful. That means that there hasn't been a horizontal stretch, so my b value is just going to be 1. That's great. Which means if I go from here to here, my minimum is going to be halfway in between those two. Okay, which is going to be basically pi units from negative pi over 2. If I go forward pi units, I'm at positive pi over 2. And so now, there's my middle, there's where I'm crossing the midline here. So the graph has got to look something like this. Okay, so we want a sine function, and I'm assuming a positive sine function, although we could come up with a negative one here. So my graph is going to look like this. It's going to be 3 sine of 1x, and I'll figure out the phase shift in just a second, plus 2. Well, if I want it to be a positive sine graph, it could be starting here. Now, quite honestly, it could also start there. Both on the middle, both going up, and they're basically both the same distance away from the y-axis here. So a little bit of symmetry here. So this could be plus or minus pi. Or it could, because it didn't tell me that this was supposed to be a positive or negative sign, this could be negative 3 sine x plus 2. But in this case, it's quite clear that the starting point for that sine would be at the center going down. That's right on the y-axis. I would leave it like that. I mean, I'd probably write it a little bit different without that gap there. But again, just so that you understand that there is a step here. I wrote this out, and then I look for my horizontal phase shift. Turns out there wasn't one. Okay, now finally, one more. Determine the equation of the sine graph with the function. Okay, we've got a minimum at negative pi 2. So negative pi 2, there's a minimum. And the nearest maximum to the right is at 0, 6. So 2, 3, 4, 5, 6. So right there. Okay, so I know that my max is 6. My min is 2. That means my a value here is going to be 6 minus 2 over 2. Well, that's 4 over 2 is just going to be 2. The d value will be 6 plus 2 over 2, and that's going to be 4. So here's my middle. Okay, there's my max, there's my min. I know that halfway in between those two, so from 0 to negative pi, halfway is going to be negative pi over 2. I'm going to hit the middle, okay, because there's symmetry here. It takes me a quarter of a period to go from the bottom to the middle here, and then another quarter to get from the middle to the top. So there we go, there we go. So now pi here is a half period to go from bottom to the top, which means my full period is going to be 2 pi. Why did I hesitate there for a second? That was weird. 2 pi. And that's great because that means my b value once again is 1. So it's going to take me another pi over 2 units to get to the middle and another pi over 2 units to get to the bottom. Now, this is still supposed to be a sine graph. And again, we haven't identified whether this is a positive sign or a negative sign here. So we'll take a look at both here. So it would be, let's say positive sign will be 2 sine of 1 x something plus 4, or negative 2 sine x something plus 4. Now, positive sign starts at the middle and goes up. So there would be a good starting point for positive sign, and that's going to be pi over 2 units to the left. Negative sign would start at the middle and go down. So there's a good starting point for negative sign. So that'll be minus pi over 2. And then that means pi over 2 units to the right. Okay, and so there we go. So I hope that just fills in just a couple of the gaps that might be in that particular lesson.